Welcome back to Science to Sleep By. Tonight, we drift far beyond the planets, beyond the edge of sunlight, into the quiet darkness where humanity's oldest space travelers still continue their endless journey. More than 40 years ago, NASA launched two machines that changed history forever: Voyager 1 and Voyager 2. Tiny robotic explorer carrying golden records, human voices, and our curiosity into the stars. They traveled farther than any human made object ever has. But here is the strange question many scientists and dreamers still ask today: if Voyager was such a successful, why have not we launched Voyager 3? Tonight, we'll slowly explore the science, the engineering, the politics, and the deeper human reasons behind that mystery. In a calm journey through space, time, and the future of exploration. When scientists at NASA designed the Voyager missions in 1970s, they were not trying to build immortal spacecraft. In fact, many engineers believed the probes might survive only a few years. But Voyager 1 and Voyager 2 became something almost mythical in modern science. They used a once in 170-year alignment of the outer planets, allowing one spacecraft to slingshot from Jupiter to Saturn, then onward towards Uranus and Neptune, using gravity itself as fuel. This was not merely good engineering. Scientists often describe it as one of the luckiest opportunities in the history of space exploration. The Voyagers revealed volcanoes erupting on Jupiter's moon Io, hidden oceans beneath icy worlds, and storms larger than the Earth itself. Even today, Voyager 1 continues sending faint whispers from interstellar space nearly 15 billion miles away. But the reason we have not launched Voyager 3 is partially because recreating that mission is nearly impossible. The special planetary alignment no longer exists. A new spacecraft would need far more fuel, far more time, and vastly more money to repeat the same grand tour of the outer solar system. Scientists today explain that the original Voyager missions succeed because they combine perfect timing, Cold War funding, scientific ambition, and a public fascinating with space that allowed the Apollo moon landings. Modern missions are built differently now. Instead of one spacecraft trying to visit everything, agencies prefer specialized probe designed for specific targets. That's why we have missions like Juno studying Jupiter or New Horizons visiting Pluto. In many ways, Voyager was a product of unique historical moment that may never happen again. And perhaps that is part of why people still romanticize it so deeply. Voyager was not just a spacecraft, it was humanity throwing a message in a bottle into the cosmic ocean without knowing whether anyone would ever find it. One of the biggest reasons scientists have not launched Voyager 3 is surprisingly simple. Deep space missions are incredibly expensive, painfully slow, and politically difficult. Voyager 1 took years just to reach Jupiter. A modern Voyager style mission could take decades before producing major discoveries, and in today's world, governments often prefer projects with faster results. Scientists working in planetary science frequently explain that funding space exploration is a constant battle between ambition and practicality. Building a spacecraft capable of surviving 50 years in deep space requires extraordinary engineering. Unlike missions near Earth, solar panels become nearly useless far from the sun. Voyager and radio isotope thermoelectric generators powered by plutonium to create electricity. But plutonium production is limited, highly regulated, and extremely expensive. Engineers would also need communication systems capable of sending signals across billions of miles, where even light itself takes nearly a full day to travel. Every command sent to Voyager moves at the speed of light, yet still arrive incredibly slowly because space is unimaginably vast. Scientists must also think about reliability in a way unlike almost any other machine on Earth. Once a spacecraft leaves Earth, there are no repair shops in interstellar space. Every wire, computer, and instrument must survive freezing darkness, radiation storms, and decades of isolation. But perhaps the hardest challenge is human patience. The people who launch such missions may retire before the spacecraft reaches its most important destinations. Some scientists who work on Voyager have already passed away while the probes continue traveling silently outward. Modern space agencies often prioritize missions that can produce discoveries within political election cycle or within a scientist's career timeline that create a strained tension between human lifespans and cosmic exploration. Voyager succeeded partially because an earlier generation was willing to invest in something whose greatest rewards must not arrive for decades. Today, scientists still dream of sending another interstellar probe, but they know it would require nations to think not in years but in generations. Interestingly, many scientists say they don't really want a Voyager 3 at all. They want something far more advanced. Since the 1970s, technology has transformed dramatically. The original Voyager computers were weaker than modern calculators, yet they crossed the solar system. Today, researchers are imagining spacecraft powered by iron engine, nuclear propulsion, laser sails, and even artificial intelligence system capable of making independent decisions in deep space. Some concepts could travel faster and farther than Voyager ever could. Scientists at organizations like Jet Propulsion Laboratory often discuss future interstellar probes designed specifically to study the mysterious boundary between our solar system and interstellar space. Voyager was never originally intended to leave the solar system forever. It simply kept surviving. Future missions may intentionally aim toward nearby stars or investigate the strange bubble created by the sun's magnetic field. Researchers also hope future probes could carry more sophisticated cameras, advanced particle detectors, and perhaps even tiny robotic landers for icy moons. But modern scientists face another difficult question: should humanity spend billions sending robots further than darkness, or should we focus on returning humans to moon and eventually Mars? Space budgets are limited and every major mission competes for funding. Some scientists argue robotic exploration give better scientific value with low risk. Others believe human exploration inspired the world in a way robots never can. Meanwhile, private companies are also reshaping space exploration. Firms like SpaceX are pushing reusable rockets and reducing launch costs dramatically. This could eventually make deep space exploration cheaper and more realistic. There are already serious scientific discussion about interstellar probes that could launch within this century, but they may not carry the Voyager name because scientists believe the future deserves something entirely new. Voyager represent the dreams of 1970s. The next great interstellar mission may represent a completely different era of humanity, one shaped by artificial intelligence, international cooperation, and technology still being invested today. Perhaps the real reason people keep asking about Voyager 3 has little to do with spacecraft at all. The question touches something emotional inside us. Voyager represents hope, curiosity, and strange human desire to reach beyond our own world. Scientists often speak about Voyager golden record with deep affection. Inside these spacecraft are sounds of Earth, laughter, music, whale sounds, greeting in dozens of languages, and images of human life. It was humanity introducing itself to the universe. Carl Sagan and his team understood something powerful. Long after nations change, governments disappear, and civilization evolve, Voyager may continue drifting through the Milky Way for millions of years. In some sense, Voyager became humanity's longest lasting monument. And maybe that is why people wonder why we have not repeated it. The truth is that modern science has become more careful, more specialized, and sometimes more practical. But Voyager came from an era when humanity still openly dreamed about the stars with enormous optimism. Scientists today still carry that same curiosity, but they work within tighter budgets, more complex politics, and a world filled with immediate crises on Earth. Yet, despite all of this, the dream has not vanished. Somewhere tonight, engineers are designing engines that don't yet exist. Physicists are imagining way to cross interstellar distance faster than ever before. Young students are looking through telescopes and wondering that what lies beyond the edge of solar system. Voyager itself continues traveling silently through the darkness, carrying Earth's story farther every second. And perhaps that is enough for now. Perhaps Voyager 3 has not launched because humanity is still deciding what kind of civilization it wants to become before sending its next message into eternity. Until then, the two original Voyagers continue their quiet voyage through the stars, reminding us that even tiny machines built by fragile humans can travel farther than anyone once believed possible. If scientists ever decide to build something the world called Voyager 3, it will almost certainly look nothing like the original spacecraft from the 1970s. Engineers today imagine missions powered by technologies that once sounded like pure science fiction. Some researchers are studying nuclear electric propulsion systems that could allow spacecraft to travel much faster through deep space while using far less fuel than traditional rockets. Others are experimenting with enormous solar seals, giant reflective sheets pushed toward not by engines but by light itself. There are even serious scientific discussion about laser propulsion, where powerful lasers based on Earth could push tiny spacecraft to incredible speeds, perhaps fast enough to someday reach nearby star system within a human lifetime. Scientists also believe future interstellar probes may use advanced artificial intelligence to make decisions on their own because communication delays become enormous at extreme distances. A signal from deep interstellar space can take many hours or even days to reach Earth, meaning future spacecraft may need to react indirectly to unexpected dangers or discoveries. Researchers also hope future mission could study mysterious objects like the Oort cloud, the vast frozen shell of icy bodies believed to surround our solar system trillions of miles away. Some scientists dream about probes that could directly photograph distant exoplanets or search for signs of alien chemistry in deep space. But perhaps the most remarkable idea is that future spacecraft may not belong to one nation alone. Experts increasingly discuss international missions where many countries work together, sharing technology, cost, and scientific knowledge. In that sense, a future Voyager 3 might become more than an American spacecraft. It could become humanity's spacecraft, a shared attempt by our species to understand the enormous universe surrounding the tiny blue world we all call home. And so tonight, as Earth turns quietly beneath the stars, Voyager continues onward through the infinite dark, carrying the sound of our world into a universe we still barely understand. Maybe one day humanity will build another great interstellar travelers. Maybe it will be faster, smarter, more powerful than Voyager ever was. But the true legacy of Voyager was never only about distance, it was about curiosity, about courage, about the human need to explore what lies beyond the horizon. And somewhere unimaginably far away, our little spacecraft still whispers into the cosmos. We were here. Thanks for watching. Good night.